website for
Yes.
interesting events.
Well, thank you for inviting me to talk, Piero. I prepared a playful talk on something I've been very into lately, and that is using found objects for musical instruments. There's a lot of precedent in this in experimental music. What I think maybe is novel is we have access to digital fabrication. So I've been doing a lot of 3D printing and printing these prosthetics, musical prosthetics for found objects. The sweet spot of 3D printing is when something needs to be completely customized. So it's a very useful technology in the biomedical field, of course, but also in a much more artistic context, when you want to take an object that you find in a boneyard and turn it into an instrument, you can customize some extension to it. So that's kind of what I hope comes out of this. I'm going to show a lot of examples of other work that's kind of inspired me recently. Two choice quotes. American poet Mark Strand: "A rough sound was polished until it became a smoother sound, which was polished until it became music." I like to contrast that notion of instrument building, if you can see a notion of instrument building there, with Bart Hopkin, the area instrument builder, who says, "It will be tempting to turn each sound generating system into a pitch selection and rhythm control device. After all, that is what most musical instruments are and what most instrumental music is composed for. But it may be that to do so is to impoverish the sound, try to let the instrument and its sound suggest their own music." So I see kind of a contrast here of building top-down instruments from repertoire and from known geometries and known resonators that work very well, and almost a bottom-up approach of finding interesting debris and testing it to see what sound it makes, and a more exploratory approach. And I'm definitely more in the latter. But 3D printing has been used for the former, and this is the stories that have made a lot of media splash, where you 3D print an acoustic guitar like Scott Summit did, or Amit Zoran's flute, or Olaf Diegel's drums, and a violin from a German company, I believe. More proof of concept. We are perhaps excited because you can do it, and therefore, at least momentarily, we accept that the sound isn't quite up to speed for the standards we hold to these kinds of instruments. And here's Bart Hopkin's work at the Center for New Music, and clearly we see found objects, resonators attached to different kinds of structures, exploring the sound in a more bottom-up approach. If we zoom in on one of these instruments, we see he even uses branches, so some organic, some trees' quest for light now becomes the way bells are distributed. And you have to learn this instrument. It's part of the fun of constraints of it. Victor Gamma is a visiting scholar in our department this quarter, and he introduced me to this wonderful project that he did that was eventually taken up by the Kronos Quartet. He was born in Angola and discovered a few years ago that the children repurpose military debris to make instruments. And this is an ammunition box, and the children didn't even drill the holes. Those are actually bullet holes, and they made these stringed instruments. Here's a magazine filled with corn as a shaker. Kind of very, very poetic and compelling, this kind of redemption of otherwise destructive objects. I teach a workshop called the 3D Printing for Acoustics workshop in the department in the summer, and one of the students this year, Matt Gilbert, really perceived the great affordance of digital fabrication. He tried to replicate one of the instruments that rivals for the oldest instrument in the world, this bone flute, Paleolithic bone flute. And so he found documentation online and traced it and replicated the flute. So this is one of the exciting applications of 3D printing. And he put it online, so now you can download his best approximation of this very ancient flute and try to play it. He was learning it during the workshop. It was exciting. These are Strombus shells, a very early example of found objects, organic objects used for instruments. You cut off the top of them and even can apply material to improve the mouthpiece. These are used as trumpets. And some of the earliest ones are dated to 3500 BC, so they're very old instruments. With the advent of ceramics, the same kinds of geometries were created, but now, of course, with a little more flexibility. And I do see a funny analogy between 3D printing and ceramics in that if you tackle the machinery of computer-assisted drawing, suddenly it's a very malleable tool, and you can take an instrument that you know very well and mutate it and try it out. So it led in Peru to these whistling vessels much later that are clearly much more artifice involved. These aren't found objects, they're fashioned objects. However, I was inspired by these and wanted to make some. There's many ways you can. You can make modern ones out of ceramics. But I thought, well, let's try to find some. So in my digging through boneyards, I discovered that the motorcycle gas tank has the requisite U-shape. So the way the whistling vessel works is water flows between the conduit, and it's like a lung. It pushes air and draws air out of either side respectively, depending on how you tilt it. And if you sculpt a whistle into the top, or several whistles, you can even make a polyphonic instrument. So quickly prototyping different kinds of whistles for these gas tanks. They rock in the street here at the San Jose Biennale, and I collaborated with Chris Chafe and Dan Fredrickson on this project. I think the video should work. So here's how they sound. They're totally acoustic instruments, basically using 3D printing to provide a musical prosthetic for otherwise discarded objects. You can even play them. You can hear the whistles changing modes. So there's the 3D printed whistle, and by varying the length you get different pitches. I was recently invited to go to Beijing with the Stanford Laptop Orchestra and workshop new pieces for this ensemble of computer musicians. And with composer Kitty Shia, we decided that we would also do a found object piece. Whenever the group went out for dinner, of course, we just loved these giant glass Lazy Susans. And so Kitty and I decided that we were going to create kind of a social instrument where we pass mundane objects to each other around this table, and we would hit them and record them and live sample them and then process them on computers using game controllers. So these are the objects we collected during our workshop, and they weren't exactly musical objects, but we insisted on playing them that way. There's the laptop orchestra surrounding the table, and they would live record any snippet of sound they wanted to, and then at pre-composed times they would manipulate those sounds in the software Chuck that we use. So here's a few of the elements of that piece, much foreshortened for the constraints of time. There's also a phone on the table sending angular data for the bass. So the whole table is a giant knob as well. So I'm actually holding a game controller up that has pre-recorded, not pre-recorded, but live sampled some sound from Kitty. It's hard to see behind that. So now the ensemble has chosen the samples to record, and they're manipulating This gramophone was a very stylized instrument I built for Yar Kapuscinski, a composer in our department. And it mixed some noise with some pre-recorded files from the ensemble. And it was commissioned specifically for a composed piece he did for the San Francisco New Music Players at the Yerba Buena Center. I don't really want to talk much about this because I'm actually more interested in what was left over from this project. I had to order these little plastic wing nuts. And you can see the bolts in there. That was the first way I held this paper mache horn together, and then I paper mache'd over it so I could actually take them out. But I had to buy an excess number of these things, so I had them left over. So here's the next example of 3D printing as sort of restoring the function or totally adapting the function of an otherwise wasted leftover from a project. So I flipped the wing nut around and I 3D printed this little clamp to hold a piezoelectric microphone to our 3D printer. When you have a 3D printer in a music department, no one cares what you're making. They just are fascinated with the sound. If you look up printer music, there's all kinds of use of these stepper motors to make music. So I made a few of these and attached them to our 3D printer. That's a piezoelectric microphone. And with the bolt, you can vary the pressure. So we've put the printer in a few concerts now, and it's sort of printed its own set of extensions. And I basically improvise on the machine while it's warming up. And then we've basically composed a shape that we like the sound of, where the extruder is making certain rhythms that we enjoy. So I also used the wing nut, flipped the wing nut so that it would become the tuning mechanism to a string. So on the side of the printer now is sort of a harp, and you can tune these strings. And because the printer's wood, it's very resonant. You can pick up all these sounds. So we're kind of here's a few snippets from experiments. The sound was live processed by my collaborator Fernando Lopez Lascano. These are snippets from the Transitions concert that Yara mentioned. So the machine is warming up now, and I basically improvise on it. You can see the strings on the bottom right there, just a reflection of light. So that was in a multi-channel space. I think there was 22 channels. And so it was spatialized, and the sound was thrown around. It doesn't quite capture it here, but and finally, the most recent and very playful experiment with just going to a scrapyard and saying, "Hey, what can I transform into a musical instrument?" Happened recently when I went to Allen Steel and discovered this bin of discarded portafilters. You can see them there in the middle in the green bin. Those are, the carriers of the filter for an espresso machine. And I thought, as a musician, I can't help but seeing a small stringed instrument in that thing. And so this is a manipulation of scale, but I decided, yes, I must go back to the shop and quickly make a soundboard for this object that is destined to be melted down. And so it attaches to the bottom threaded aperture at the bottom so that the tension of the strings doesn't pull it off, and you can see the holes for the strings. And then I had to make basically a neck that would somehow attached to the hexagonal cavity in the back of the handle. If any of you make espresso, you know that there's this nice cavity that can be used in this way. And then the tuning pegs holes are in the back, although I'm going to move them to the side. I bought a few of these to make a set, but of course each portafilter has a hexagonal cavity that's at a different angle. So this is sort of, in some ways, necessitates digital fabrication, where you can go into the model every time and just change the angle of the fixture. And so here's the final instrument, and I think we're going to call it the Javelele, or my partner Erica also proposed banjo with an E. So maybe we should do a vote. But that's sort of where I am right now in terms of my own work. I find it really fun and playful to sort of find things and use 3D printing to bring them into some sort of musical application. Thank you.